Welcome to my 11th tutoring session in A-level chemistry. In this video, I'll talk about size of electrically neutral atoms and charged ions. I'll end the session with some practice questions to gauge your understanding of the topic. In order to understand the topic size of electrical neutral atoms and charged ions, one need to be familiar themselves with the meaning of neutral atoms and charged ions. What are ions? Ions are electrically charged particles that result from the gain or loss of one or more electrons by an atom. And they can be either positively charged, called cations, or negatively charged, called anions. For example, sodium chloride. In a neutral atom, the total number of protons will be equal to the number of electrons. So it is the attraction and balance between the protons and electrons that holds the atom together and keeping it electrically neutral. So when the number of protons are equal to the number of electrons, that gives us an electrically neutral atom with no charge. A neutral atom loses an electron and a cation is generated. So in the resultant cation, the number of protons will be more than the number of electrons. So there will be increase in the number of positive charge, and thereby the attraction increases and the size decreases. When the neutral atom gains an electron, an anion is generated, and in the generated anion the number of electrons will be more than the number of protons, and this leads to repulsion, spread of negative charge, and moreover the space occupied by the new electron will be increased, and finally the size of the anion increases. The electrostatic force of attraction between the positive charge and the negative charge increases when the distance between them decreases. And the attraction between the positive and negative charge will be moderate when the distance is moderate, and the attraction between the positive and negative charge decreases when the distance between them increases. So therefore the electrostatic force of attraction between the positive and negative charge decreases with increase in distance between the opposite charges. Let me explain with an example. So let me consider an electrically neutral atom with 3 protons in its nucleus and 3 electrons in their respective shells or energy levels. This is an electrically neutral atom. It has no net charge. And when this neutral atom loses an electron, a cation is generated, and you can see the number of electrons is reduced by 1. The total number of protons is 3, while the number of electrons is 2. And as a result, the size of the cation decreases. So after the neutral atom has lost an electron, there is an increase in the positive charge, and therefore the attraction between the positively charged protons and the 2 electrons that is left over increases. Repulsion decreases because the total number of electrons is only 2, not 3. And as a result, the effective nuclear charge increases. Now I have given the link in the description about my previous video explaining the effective nuclear charge. You can follow that. And finally, as the effective nuclear charge increases, the size of the cation shrinks. On the other side, when the neutral atom gains an electron, the number increases to 4. And with the entry of the new electron, there is a repulsion between the electrons, and as a result, the size of the anion increases. So the size of the anion increases because of increase in the negative charge. As a result of increase in the negative charge, that is arrival of new electron, repulsion increases. The electron shell with a new electron leads to expansion. There is the expansion in the electron cloud. It occupies more space and the effective nuclear charge decreases because the repulsion takes over the attraction between the opposite charges. Now, ions are formed from the neutral atoms when the atoms undergo a process called ionization. So, ionization is a process involving the formation of ions because of the gain or loss of electrons. Let me give a specific example of lithium atom with a size of 167 picometers. Now, lithium atom has 3 protons in the nucleus and 3 electrons in the respective shells or energy levels. When the lithium atom undergoes ionization, it loses its electron in the outermost valence shell, and that leads to generation of lithium ion, and 520 kilojoules per mole of energy is required to remove this valence electron from the lithium atom. And after the electron is lost, you can see the number of protons are more than the number of electrons, and that leads to increase in the attraction, and as a result, the size of the resultant lithium ion decreases. So because of the increase in the effective nuclear charge, that is the attraction between the 3 protons in the nucleus and 2 electrons in the first shell, the size of the cation shrinks, and as a result, the size of the lithium ion decreases. So you can see when you compare and contrast the size of the lithium atom to that of the lithium ion, you can see that the size has reduced from 167 picometers to 76 picometers. The size of atoms and ions are generally measured in picometers, angstroms or nanometers. 1 angstrom is equal to 10 to the power of minus 10 meters or 100 picometers. In most cases, you will find the unit picometer because it is very convenient to compare the size of atoms and ions using this unit, that is picometer. So let me give you one more example dealing with the size of both cations and anions. So example will be the formation of sodium chloride. So electrically neutral atom, the number of protons will be equal to the number of electrons, leaving it electrically neutral with no charge. It loses an electron, a cation is generated. The size of the cation decreases because the number of protons are greater than the number of electrons. The neutral atom gains an electron, anion is generated. The size of anion increases because the number of electrons are greater than the number of protons. Now, in case of electrically neutral sodium atom, there are 11 protons in the nucleus and 11 electrons in the respective shells or energy levels. And in case of chlorine atom, there are 17 protons in the nucleus and 17 electrons in the respective shells or energy levels. So the balance is maintained. So the number of protons is equal to the number of electrons in both the case, and therefore they are electrically neutral. Now when the sodium loses its only valence electron from the outermost shell to the electrical neutral chlorine atom, so let's see what happens. You see the shell has disappeared. This results in formation of sodium ion and chloride ion. Let us count the number of protons and electrons after the formation of sodium ion and chloride ion. So in case of sodium ion, the number of proton is 11, but the number of electron is reduced by 1. In case of chloride ion, the number of proton is 17, but the number of electron is increased by 1 number, that is 18. Now the sodium atom, the electronic configuration is 281. Now sodium atom has lost its only valence electron in order to attain the stable electronic configuration of neon, that is 28. Now the chlorine atom has an electronic configuration of 287. It has gained an electron from the sodium atom in order to attain the stable electronic configuration of argon, is 288. Now I explained in detail about the driving force for the formation of the salt sodium chloride in my previous video, and I have given the link to that interesting video in the description. You can follow that. Now after the formation of sodium ion, the effective nuclear charge increases, that is the attraction between the positively charged protons in the nucleus and the electrons present in the shells increases, that is the outermost shell increases, and thereby the cation shrinks. Now in case of chloride ion, with the arrival of the new electron in its third shell, you can see that it has occupied an extra space, and after the arrival of the new electron in the third shell of chlorine atom, you can see that it is experiencing enormous amount of repulsion with the neighboring electrons present in the same shell as well as the electrons in the inner shell, and this leads to expansion of the chloride ion, and therefore the size of the anion, that is chloride ion, increases. Now the atomic radii of sodium is 190 picometers, and after it has lost an electron, you can see the size has reduced almost half. It is 102 picometers. And what about the chlorine atom? Its atomic radii is 97 picometers, and after it has gained an electron, its size increases. Its ionic radii is 181 picometers. The size is almost doubled because of the repulsion it is experiencing and corresponding increase in the space it has occupied, the shell. So let me help you with the practice questions relating to the neutral atoms and ions. The first one, which atom is electrically neutral? So you have to select the option where the atom is not bearing any charge. So look for the atom that is not bearing any charge, or the atom which is neutral. So it is phosphorus. So phosphorus is the only option because it is the atom without any charge. Second question, which cation has a greater positive charge? Yes, so you have to select the ion with the greater number of positive charge, that is 3 plus here. So it is the ferric ion with the greater number of positive charges as compared to the ferric ion with 2 plus and the other ion with only one positive charge. Now, which ion has a greater negative charge? Yes, so it is the nitride ion with three negative charges as compared to two negative charges in case of sulfide ion and only one negative charge in case of bromide ion. So the answer is nitride ion, bearing three negative charges. So next question is going to be a interesting one, and arrange this in the order of increasing size. So whenever you get a question relating to the order of increasing size of a given element, so always you start with the neutral form of the atom. So in this case, the atom in question is magnesium. So in case of electrical neutral magnesium atom, you know that a neutral atom, the number of protons is equal to number of electrons. So there are 12 protons in the nucleus of magnesium atom and 12 electrons in their respective shells or energy levels. So it's electrically neutral with no charge. Now after it undergoes first ionization, it loses its first valence electron, and further it undergoes second ionization, losing its second valence electron, and finally it undergoes further ionization, losing its core electron. And you can see that the oxidation state of magnesium has increased from 0 to +1. Then after it has lost another electron, it changes to 2 plus and then 3 plus after losing the core electron. Now after losing its valence electron, the first valence electron, after it has undergone the first ionization, Mg plus is generated, cation. So after the generation of Mg plus, the effective nuclear charge increases, which is the attraction between the protons in the nucleus and the valence electron as in the outermost shell, and thereby because of the attraction, the effective nuclear charge, I mean the size of the cation shrinks. Now further loss of one more electron leads to generation of Mg2 plus cation. Further the effective nuclear charge increases and a further decrease in the size, and after losing one more electron, there is further increase in the effective nuclear charge, and thereby the size further reduces. As the number of electron decreases, the effective nuclear charge increases, and thereby the size decreases. So the order is Mg3 plus less than Mg2 plus less than Mg plus, and the neutral atom of magnesium will be the one with a bigger size. The last question, arrange these ions in the order of decreasing size. So you know that the ion with the greater number of positive charges will be the smallest one because of the highest effective nuclear charge, and therefore the order will be. So the neutral atom will be always bigger in size as compared to the one with greater number of positive charges. Now I'll end my session with the practice questions. These two questions will be the homework practice questions relating to the neutral atoms and charged ions. Now the answer to these two questions, I'll give a hint. The answer to these two questions will be the topic for my next video. So you have to watch out for my next video, and answer to these two questions will be the topic of my next video. Thank you so much for watching my video. Hope you enjoyed it. Don't forget to subscribe, share, like my videos. I'll meet you in my next interesting tutoring session.